Welcome back to the morning show. We're here with our wise guy, Matt Sullen. Thanks for being with us as always. And you're here to talk about why matter matters. How's it?
Yes, that's right.
All right.
And so the question I asked last time for the viewers was, if you have a gas, you can always sort of compress it and make it occupy a smaller volume, but if you have a liquid, you can't. So I have a demonstration of that right here. Here's a syringe I bought at Farm and Fleet, and I just plugged the end up with a toothpick and some glue, and I can grab this thing and I can squish it. See that? And so whatever that volume is, I can make it smaller just by squeezing on it. That's because that's a gas, and it behaves differently than a liquid. Here I have some colored water. If I just plug that end with my finger, I can't squish this at all. This thing is completely incompressible. And the reason for this is because things are made of atoms. And the way atoms behave is differently for gases and for liquids. And so if you think of an atom like a little tennis ball or something, if you pack all the tennis balls together in a bag, you can't really squish them together anymore because they're already touching. In a gas, however, so that would be a liquid. In a gas, they would be one over here, one down there, one up there. There's space between all the atoms, and they're moving around really fast. And so gases take up a lot more space than liquids do. And you can illustrate this with guess what? You know,
liquid nitrogen.
Right. Any excuse to play with my favorite liquid here. So if I stick a balloon into this stuff, what's going to happen is the balloon is going to start to shrink.
Wow.
Decompressing.
It's sizzling.
Well, what's really going on is what's inside the balloon, of course, is air. Air is mostly nitrogen.
Right.
And so what's happening as this stuff gets cold, the nitrogen, which is a gas inside here, is turning into a liquid.
Look at that.
And so I've already done this to a balloon because it takes a little while. So let me just fish it out. Here's one I put in there a bit earlier. And if you can zoom in on this a little bit, you'll see that in the bottom of this thing, there's kind of like a little puddle. See the little puddle?
I see that. What is that exactly?
That is liquid air. That is liquefied air.
Liquid oxygen?
Liquid nitrogen, basically.
Okay.
Yeah. So that's what happens when we stick this thing in there for long enough. You see that it starts to get smaller.
And it liquefies the air.
Yeah, it's not that anything is leaking out of this thing. What's really going on here is that all the gas that's in here, the atoms are getting closer and closer together. Eventually they form a liquid where they're all touching and they take up much, much less space.
Now, what's the significance of this liquid nitrogen you're putting it in? Is it real cold? I mean, that's what it looks like.
This stuff is very cold. Liquid nitrogen has a temperature of about 77 degrees Kelvin, which is a couple of hundred degrees below 0 Celsius.
Wow.
And so it's cold enough that it can turn a gas basically into a liquid. And we played with this last week, and Matt had fun with a hammer, which I brought again, by the way, so you can have some fun with it. And what we're going to do in the next segment is we're going to use liquid nitrogen to illustrate that a gas takes up a lot more space than a liquid does. So here you can see.
So can you pop the bottom of the balloon and have liquid air spill out all over the...
Yes, we could. Or we could just spill it like this.
Oh, boy.
And there it goes.
Wow.
Now, if it goes in your pocket, you have to, run. Anyways, so what we're going to do next time is we're going to illustrate that a liquid takes up a lot less space than a gas by making an explosion.
Not to get off topic, but could we go buy this at Farm and Fleet?
Probably not. No. Although, they do use this stuff for artificial insemination to keep the...
Well, we'll let them have that.
So you probably could buy it.
We'll keep that in mind next time we go to Farm and Fleet.
Well, we can make Robert jealous. We have a giant canister of liquid nitrogen that's down there that you brought, Matt.
That's right. And I was going to... And I'll bring again next time because we're going to do something else that has to do with cold. But let me say real quick, the person who explained the difference between a gas and a liquid really quite well, that was pretty good, in an email that he sent me was Jake Derricks from Mount Zion, and so he's getting a T-shirt.
Yeah, we're getting closer to doing the weather on the 3s. So I think with that popping, we'll go to break and we'll come back. We'll see you in about 20 minutes.
All right, sounds good, Matt.